Hello everyone. Yes, this moment I want to share you about how to solve one question regarding electric field. Yeah, this is a subject physics AS or A level paper test. I don't remember again what the year is. Yeah, but actually I want to share you about how to solve some equation, some question. Uh, but don't forget, before we continue about my video, don't forget to subscribe my YouTube channel, comment, like, and share, or post the button notification. So the question is, the diagram shows the path of electron in uniform electric field between two parallel conducting plate AB and CD. The electron enters field at the point midway between AD. It leaves the field at B. Okay, this is curve of electron path. Yeah, and this is about the electric field. So, question A is mark on diagram the direction of electric field. So, the best knowledge about the how to find the direction of electric field, we have to know about the Coulomb's law, attraction or repulsion force. So we know the electron is negative charge. This is negative charge. So if the negative charge, it will going or it will attraction with the different charge. So actually this is around positive. Why? Because the electron coming to positive, the electron negative, and they will be going to positive charge. So if AB plate AB is positive, so plate BC is negative. Yeah. And we can consider that the electric field, it will be going down. This is the electric field E. Coming from plate AB into plate CD. Okay, so question B, yeah, that going down, yeah, from plate AB to CD. Okay, continue to the next number about the little bit calculation. On the question BI, the conducting plate are apart 5.0 centimeter apart and have potential difference to 150 volts between them. Calculate the force on the electric due the electric field. Okay, if the distance between two plates is 5.0 centimeter and the potential difference around 250 volt. So we can say that the force equals to QA. Yes. So A or E, yeah. This is about Q electron and this is about V over B. Oh, my marker. So I will find the marker first. Okay. And we have force equals to the electron charge is 1.6 times minus 90 coulomb and V is 250 volt divided by D is 5 times minus 2 in meter. Yeah. So we can get about the, we use calculator first to calculate these numbers. Yeah. 1.6 times 250 divided by 5. Yes, 80. This is around 80 times, okay, 9, this is minus 17, or let's say 8.0 times minus 16 Newton. Yes, this is force do the electron well when he coming from a middle of a AD to point B. So the next question is, to lift the electric field at B, the electron must enter the field with a speed of, wow, at B they have speed, yeah. At the point B, the electron, uh, they have V on B, it's around 1.30 times 7 meter second minus 1. So, calculate the potential difference required to isolate an electron from rest to this speed. Okay, potential, potential difference, yeah, PD, how much PD is. Okay, uh, this is about the energy electron when they move from the middle of AD to B point. So this is about the electric, kinetic energy. Yeah. Kinetic energy change into potential energy. So the kinetic energy means a half mv square, and potential energy equals q electron lv. So V is potential different. So we can say V equals to a half mv on B divided by q electron. Or if we calculate with this number, so we have mass is around 9.131, and Vp we have 1.30 times 7 times 7 square, yeah. And we have 2, yes, 2. K electron is 1.6 times minus 19. So we can calculate these numbers, yeah. This is around, let me calculate first this number, 9.1 times with 1.2, 1.3 times again 1.3 and divided by 3, 3.2 here. Yes, we get 4.8. Yes, this is around 4.80 times, let's say, okay, 31. We use calculator again to know how the power of 10 is. 31, yeah, minus 14. This is coming 17, 17 minus 17, and then, okay, minus 2, and then, oh, 2, 2, 2. This is on 2, yes, volt. So we can say this is around 40, 80 volt. Yes, this is potential difference if the electron move on the point B is equals 1.30 times 10 to the power of 7 meter second minus 1. Okay, we continue again about other numbers. Oh, we have still D question. I want to erase first here. Yeah. Let's say here. I want to erase first. Yes, I think enough. So On the D question is DI. A very thin beam of electron enters uniform electric field at right angles. To field, the electron have the ring speed. The diagram to show the shape of beam of the move through the field. Mhm. So this is about the when the electron enter on the electric field here, like this one, and coming to point B. So the if we draw the electron, they have acceleration A, and they have force, force on the, this is force, and they have also weight, because the velocity is under, and they have an above force on the horizontal plane. Yeah. So the diagram is like this one. They have acceleration coming up, and they have move coming right, and they have force actually coming up. Yeah, and they have force to down coming down. So okay, then question II is, on your diagram label which electron have the faster speed? On your diagram label which electron have the faster speed? Yes, actually on the point B. Why? Why on the point B? Yeah, because they have acceleration, and they have, yeah, in the point, let's say this is BO, yeah, and then will be bigger until B, yeah. So VB is more than big than everything on the line before they coming on the electric field, yeah, and then the VB is the bigger one, yeah. Let's the bigger highest point on the highest point the velocity is. Okay, that's the one number. Yeah, that's the number one. Actually, we have. Let's continue about the next number. This is number 7. I need time to draw it first. Yeah. Okay. Let me see. Let me see about the number. Other numbers. Okay. Actually, this is number 7. Yeah. On this number is, we have potential, we have source energy, and we have oil here, and we have, so this is, oh, 5,000 volt, also big, and this is a node, and this is cathode. Oh no, this is emerging electric beam, emerging electron beam. Okay. Yes. Sorry. Okay, we read the question, or we read the explanation of the question here. Electrons are accelerated from rest. Yeah. V on the initial velocity, V initial equal to 0, from the cathode on the anode, yeah, of the vacuum tube through a potential difference 5,000 volt. So The question is, so that speed v uh, of an electron is lived at approximately 4 times 10 to the power of 7 meter second minus 1. Okay, let me check and let me prove about the velocity electron. This is actually about the changing between potential energy into kinetic energy. Yeah. Question A. This is around potential energy change into kinetic energy of the electron. Yeah. Of sorry, kinetic energy of electron. So we have QV equals a half mv squared. So we have root of 2 QV divided by m. Yes, this is actually uh, the formula to find how fast velocity when they come and then when they accelerate by voltage something. Yeah. Okay, we calculate this. So V equals 2. Yeah. Q electron is 1.6 times minus 19. V is 5000 volt divided by mass electron around 10.1 uh, minus 31. So let me calculate these numbers here. 2 times 1.6 equals to 3.2, 3.2, and then times 5, yes, divided by 9.1. So we have 1.75. 1.7 or 7.5 times, yes, this is wrong. Okay, this is around 14, yeah, 14. This is minus 3, yes, 14. So, if we calculate this one, yeah, root of 17, root of 16 around 4, yeah, so we get 4.0 times 7 minus meter seconds. Yes, correct. Has proven by the our calculate, yeah. So, on the B, yeah, the emerging beam of electron follows a parabolic path. It spans between a pair of horizontal parallel plates 5.0 cm apart, with a potential difference of 1400 volt between them. Okay, let me draw it first about these numbers. We have horizontal plane, and we have emerging electron beam. Yes. V. And we have distance of two plates 5.0 centimeter, and they have, this is around positive 1040 volt, and this is into 0 volt. Okay, and we have here from the here, sorry, this is about H. So we have also here is 12 centimeter. Length of plate is 12 centimeters. So On this question here, on this B question, BI, calculate the strength A. Calculate the strength A uh, when calculate the strength A of the uniform electric field between the horizontal plates. Yes, A. How to find A? A, we have, this is about V over D. V is 100, as a 1004. D is 5 centimeter. Yeah, 5 centimeter is 10 minus 2, where on the meter. So we calculate this. Yeah, this is about, yes, I want to use calculator first. 1400 divided by divided by 5, this is equals 280 times 2. So the electric field is 2.8 times 4 Newton coulombs. Okay, we find about the electric field on this diagram, on this circuit. Yeah. Hence, determine the force F exerted by this valid electron. Okay. Force, coming back from our definition about force, is UV. Yeah. Oh, sorry, QE. Sorry, this is not potential energy. QE. So Q is 1.6 minus 19, and then here 2.8 times 4. Yeah. So we can get 1.6 times with 2.8. Yes, 448. This is around 448 times 10 minus 15 Newton. Okay, we finally get the force exerted on the electron when they come off at the between plates. Okay, the C. Okay, we have other question about C question. I want to erase first. Okay, here. I want to erase here. C. Please subscribe my video, my YouTube channel. Please subscribe, like, or comment. If you interest with my video, don't forget to share with others. Okay, on the C question, an electron experience an upward acceleration A. As it travels between the plates, its vertical displacement h after a time t is given by. Okay, we have on the C question, we have the question of half a t squared. So calculate the value of h of electron leave the plates. Oh, how to find this? How to find this? We have 12. Actually, on the 12th direction, on the horizontal direction, they have no acceleration. So we can find the time electron when they start on the electric field until the position here. Yeah. So let's say on the x direction we have v. Yeah. V still VO. And times t, so we can say v under x over t, and then x is 12 centimeter, or 12 times minus 2 in meters. Oh, sorry, we find t first here. T equals v, and we have v around, oh, v is 4. I see again about 4 times 7. 4 times 10 7. So we get T is 3 times minus 9 second. Oh, so fast. Yeah? So after this, we find about A, or A equals to F divided by M. So we can say here if we directly, this is about a half F over M, and T is here, yeah, T square. So we have, yeah, F around 4.48 times 10 minus 5, 15, divided by 9.1 times minus 31, and then T is 3 times minus 9 second square. Finally we get this here. So if we calculate this, by using the calculator, so 4.48 times 3 times 9, yeah, because 3 is square, times 9 divided by 18.2 divided by 18.2, so we have number 2.21. Yes, here is 2.21 times. Okay, we find first about this one. Let's say minus 15 minus 18 and plus 31. So we have minus 2. Okay, h is minus 2 meter. So we can say this is about centimeter, right? So actually this is same thing with 2.21 centimeter. Okay, finally we get about h is. Yeah, actually this is reliable because this is feet and this is 2. Okay, a middle of. Yeah. Then D. At to figure 2, yeah, the electron beam will follow if the potential difference between the horizontal path with decreases labeled this path A. Yeah. Okay, at the figure path, the electron beam will follow the potential difference between the horizontal beam. Oh, yes, this is. Okay, at the figure 2, yeah, the path that the electron beam both follow if the potential difference between were decreasing. Okay. Or if the potential difference decreases, it will be not like this one. It will be like this one. Yes, the path will be going down and h equals to smaller than before. Yeah. And DII at the figure 2, the path electron beam will follow the potential difference between the cathode and anode will decrease. This is label A. Sorry, this is, oh, sorry. If, I'm sorry, this is when this is B, yeah? When decreases, and then when increases is going up in this A, yeah? Sorry, I will show you again, show you again about the how if uh, at the figure 2, the path of electron beam will follow potential difference between the horizontal plates where decreased. Sorry, if the potential difference horizontal horizontally. Sorry, I will see on the figure before. Cathode anode. Oh, I see. When the cathode and anode. Okay. Okay. When the here is decreases, so yes, so this is actually it's coming here. yeah, coming here, yeah, because the decreases in here, yeah, here, and this is B, yeah. Why? Because A, if the potential here decreases, and B, when the potential on the figure 1 on the cathode and another decreases, so the electron on here, it will be the less velocity, or it will be small velocity than before. So if the small velocity than before, it will be the move, it will be going slow down, yeah. So the path is from for A is here when the potential here is decreases, yeah, and if the potential on the anode and cathode decreases, so they come here the velocity on V initial, it will be less than before. Okay. Okay, I think enough for this session about the how to solve question on this paper regarding electric field. So don't forget to subscribe my YouTube video, like, comment, or share to someone else if you interest with my videos. Thank you very much. Bye bye. See you on the